This episode is brought to you by Cisco Educational Premium.
In 1494, Luca Pacioli publishes Summa de Arithmetica, a comprehensive collection of all known mathematics in Renaissance Italy. In it, there is a section on the cubic equation. By this time, people have been trying to deduce the general solution of the cubic equation for at least 4,000 years. Each civilization that faced it would not congate the cubic equation. So, reasonably, Pacioli's conclusion is that the solution to the cubic equation is simply impossible. Back in those days, mathematics was not written down in equations. It was wordy and at times poetic. People viewed mathematics literally. All mathematical concepts were drawn from the real world, and anything that could not add up was met with a lot of skepticism. Geometry was much loved as it described things that could be seen. Imagine you stepped in ancient Italy in the Renaissance period. You are a student attending some math class. You step on the door, then proceed to sit on that favorite chair and table of yours right by the corner. It is at that day of those cuts again, and you have a mathematics test. The first question you have been told to solve the quadratic equation. X squared plus 4x is equivalent to 12. Opposite to how you will complete the square algebraically, you will actually complete a literal square to solve the equation. You will be having some sort of manila paper. To solve the quadratic equation, you will cut a literal square with side x from your manila paper to represent the x squared part of the equation. After this, you will cut a rectangle of side x for the width and side 4 for the length. I will still remember that the equation equals 12. To solve this quadratic equation, you would cut your rectangle into two parts, each with width x and side 2. You would then reorganize these two rectangles with that first square with side x to form a bigger square with side 2x. This square is not complete. To complete it, you would need to add a square of side 2, which is missing in the middle. Then, because you have added 2 square on one side of the equation, you will also add another 2 square on the other side to get 16. So we have the big square being equal to 16. Then finding the square root of 16, you will find it to be 4, which will represent the side of the big square. As you can see, you can derive the value of x to be 2, because 2x is equivalent to 4. And so you would have solved the quadratic equation. Looks like you have a bright future in math. You have found the solution to be 2, right? But so is negative 6. You see, back in those days, you wouldn't consider negative 6 to be a solution because negative 6 will not be geometrically relevant. After all, how would you have a negative area? It doesn't make sense. In fact, contrary to these days where we have the quadratic formula x is equivalent to negative b plus or minus root b square minus 4ac on 2a to be the general solution to the quadratic equation. In those days, there was no general solution to the quadratic equation because those ancient ones had not accepted the idea of negative solution, especially the square root of a negative number. The same approach was taken for the cubic equation, with the search for a general solution bearing no fruit. No wonder Omar Khayyam wrote, "Maybe one of those who will come after us will succeed in finding it." Now comes another character in our story, Scipione del Ferro. Scipione del Ferro is a mathematics professor at the University of Bologna. Around the year 1508 to 1512, he finds a method to solve depressed cubics. What are depressed cubics? Depressed cubics are a category of cubic equations with no x squared term. So what does it do after solving a problem that have obsessed mathematicians for thousands of years? One considered to be impossible by Leonardo da Vinci's math teacher? He tells nobody. You see, being a full-time mathematician is hard. If you don't find an opportunity in teaching, you would need to be publishing papers frequently to live off patents. In the 16th century, it was even harder. Your job would be constantly under threat from other mathematicians who can show up at any time and challenge you for your position. There was no particular formal certification or job guarantee. It was all decided on a duel, a math duel, if you are feeling fancy. So how is this math duel done? You can think of it like those math contests you had in high school. If you were fortunate enough to attend, or are fortunate enough to attend, but more like chess. It's a one-on-one game, except it's not a game this time. Your job, your source of livelihood is at stake. Each participant submits a set of questions to the other, and the person who solves the most questions correctly gets the job, while the other doesn't, and more serve as public humiliation. So far as Del Ferro knows, he is the smartest mathematician alive, so he guarantees his job security because no one else can solve the depressed cubics. For nearly 20 years, he keeps this secret. But as with human life, we are not immortal. Scipione is now a very old man in 1526, about to pass on. Before he passes, he breaks the secret to his super favorite student, Antonio Fiore, our third character in our story. Unlike Del Ferro, Fiore is not the smartest mathematician alive, nor is he the second or even the third. He's just a regular mathematician like you and I. Okay, maybe only like me. But Fiore is very ambitious, one of those guys who will build castles in their imaginations. After Del Ferro's death, he boasts about his mathematical ingenuity and even has the audacity to dare to be able to solve the depressed cubic equations. Remember that type of cubic equations? About this time, Niccolo Fontana Totalia, another mathematician, our fourth character, moves to Fiore's town of Venice. And just so he knows who is who in the town, at least in math, Fiore plans to challenge this new mathematician, Totalia, in math duel. Remember the math duel? On February 12th, 1535, Fiore challenges Niccolo Totalia on a math duel. Totalia is a diehard. As a kid, he survived an attack by a French soldier who left his face open by a cat. That's why he is named Totalia, which translates as Tatra in Italian. Growing up in poverty, Totalia is largely self-taught, one of those self-made guys. He closed up his way to the Italian society to become a renowned mathematician. Now all of this is at stake. As in the math duel, questions are exchanged to see who wins. The visitor Niccolo Totalia decides to take the lead. He gives Antonio Fiore 30 math questions, while Fiore, on the other hand, gives Totalia 30 questions, all of which are depressed cubics. Each mathematician has about a month for the days to solve the equations they have been given. Now here's the challenge. Who will win and who will lose? Oh my. A big surprise is that Niccolo Totalia, our hardened diehard, solves all of Fiore's questions in just 2 hours, while Antonio Fiore continues to attempt Totalia's questions. What's the hurry? There is like 40 days. Right, everybody?
Cisco Educational Premium is a section of Cisco Educationals with content that is not hosted here. There are episodes ranging from long to short videos. Remember those good old shots of ours? They are there. So how do we get there? Use the link on screen or in the description or in the pinned comment below. Enjoy yourself. And I will see you in the next episode of Cisco Educationals.